Hey guys, Mr. Grand here for the 6566 review day. A couple things here. Really, the way you should use this is the PowerPoint is really your worksheet. There's a few examples that I'm going to go through, and it's really just to try to give you an extra day to sort of shore up some of this stuff. There's no assignment that's going to be turned in on this. It's just some extra practice, kind of a catch-up day as well. So we'll take it how it comes. All right, so objective, get some extra practice for these two things and try out the problems in this presentation and check the key for the answers. So the note key is sort of the worksheet key is how we should read it today. So simplest polynomials, I'm not going to go through these again, but there is a key available for this that shows how this works. The big thing is don't forget that, one, you are taking these and you're really just flipping the signs, right? So you would set this up by doing this minus 1 makes an x plus 1, this minus 2 makes an x plus 2, and this positive 2 makes an x minus 2, and then you're multiplying all of that stuff together. When it comes to irrationals like square roots and ones like this with I in them, complex numbers, these always have to come in conjugate pairs. So when I'm doing this, x plus 7 for that minus 7. This could be an x minus root 2, but I also need an x plus root 2. And then I can just multiply everything out. And that goes the same for this. There's a plus I and a minus I. Even though it doesn't tell you that in the problem, we're saying that because that always happens, it's your responsibility to understand that and recognize that you need both the plus and the minus. Okay, so the real one that I want to focus on, solving polynomials. So right now, there's a lot of different ways to do this. You do have a lot of options, and for a lot of students, this is the point where I would say, you know what, if there's just one thing that we can do and you can get good at that one thing that's going to cover your butt for everything, let's go with that. So I've got some not difficult factoring, some medium factoring, and then some ones that are really tough to factor. And we're going to do all of them just by the same process of graphing and using synthetic division. Okay, so this first one here, I'm going to start out by throwing that in my graphing calculator. And it's this top one here. So I've got everything preloaded again. All right, if we graph that, it's a parabola. It's kind of a big parabola, but I can see I've got a -9 and I've got a +6. And if I go to my table, which I should be doing, I can confirm that by scrolling up to see that -9 is indeed a 0. And scroll back down, +6 is also a 0. So, in this case, that's all I really need to do. I've got two zeros that I'm looking for because it's x squared. One of them is at -9. One of them is at +6, and that's it. I could just go x equals -9 and +6. Now, if we're specifically asking you to factor and then upload a picture of your factoring, don't just graph. But if it's just asking you to solve this, that is a way that you could do it. It might be faster to factor it, but if you just want to stick with one thing, that's the one to go with. All right, so then the next one. This is factorable by voodoo factoring, and although I know almost everyone loves voodoo factoring, there are a few of you out there that don't, and so the other thing you could do is to graph it. It looks like this. I have what appears to be a nice 0 at +3, and then maybe a not so nice 0 over here. So I'm looking for two zeros. They're both there. So the multiplicity is both going to be 1. Let's double check the table. And 3 is indeed a good 0, and there aren't any other zeros that I can find on here, so we'll go with that. So if I want to sketch the graph, a reminder, sketching the graph the way I do this is not required. I just like to do it this way. So we said positive 3 was a good one. So that means I'm going to divide out an x minus 3 by using synthetic division. 4, negative 17, 15. Remember our steps. Bring down the 4. 3 times 4 is 12. Negative 17 plus 12 is negative 5. 3 times negative 5 is negative 15. We get a remainder of 0. Good. If you didn't get a remainder of 0, you did something wrong. Okay, we removed the only whole number 0 that I could find on the graph, so now we're going to do some algebra. This is 4x minus 5 equals 0. And so we'll solve that by adding 5 to both sides. 4x equals 5. Divide both sides by 4, and we get that x is 5 over 4. So our two solutions here, one of them we found by graphing was 3, and the other one we found by factoring and algebra was 5 over 4. And just another reminder that on the test, on the concept checks, we are looking for the answer in this form as an improper fraction. So not 1.25, not 1 and 1 over 4, just like this, 5 over 4. That's going to let us know that you did things the way that we intended for you to do. Basically that you didn't just look at like photo math or something like that. Yeah, your teachers know about that. Okay, so now we've got a couple of tougher ones, not ones that are easily factorable. This one we could factor using a GCF and then maybe voodoo factoring. This one, not so much. So let's take a look at those. Start off by graphing it. All right, kind of a swoop-de like that. I've got a negative 9, it looks like. Ooh, I've got one at the origin, 0, and then I've got one over here. So let's see. We're looking for 3 total zeros, and I just came up with 2 of them. And let's just confirm it on the table. So 0 is a good 0, right? 0, 0. And then the other potential one was negative 9. Negative 9 is 0, 2. So we're good there. Okay. So the graph kind of did one of these. This was at negative 9. That was at 0. So I'm going to start out. I'm going to take out the x plus 9 that's represented by this 0 of negative 9 first. It doesn't matter which one you do, to be honest. Let's make sure that we've got all of our powers of x accounted for all the way down to the constant, right? So we put a 0 at the end here. So I've got x cubed, x squared, x to the first, and x to the 0 power. All right, then 2 times negative 9, negative 18. 15 minus 18 is negative 3. Negative 9 times negative 3 is a positive 27. Negative 27 plus 27, 0. 0 times 9, 0, and 0, like that. Now I'm going to take out this 0. So that is a factor of x plus 0 or x minus 0, which is just x. And so I'm going to throw a 0 in there. Bring down the 2. 2 times 0 is 0. Negative 3 plus 0 is negative 3. Negative 3 times 0 is 0. Like that. It's kind of nice doing this with zeros because it's harder to mismultiply. All right, so I took out my 2 whole number zeros. What I have left, 2x minus 3 equals 0. And I can solve this algebraically. Add 3 to both sides. 2x equals 3. Divide both sides by 2, and I get that x is 3 over 2. So my 3 solutions to this x to the third problem are negative 9 and 0 I found by graphing, and then the last one I had to do a little more work to come up with that 3 over 2. All right, last one. We'll graph it. I should probably erase some of my work from the last one, A. Okay, so this one, it looks like I've got a vertex here at -7 and a vertex here at +1. Let's double check our table to see that that's correct. All right, so at -7, I have a 0, so that one's good. And at +1, I have a 0, so that one's also good. So let's go back. So this one, the graph, looked like this. It was kind of a big W. This was at -7. This was at +1. So let's start out by removing an x plus 7 using synthetic division. So -7 goes in there. 1, 12, 22, -84, 49. Bring down the 1. 1 times -7, -7. 12 minus 7 is 5. -7 times 5, -35. 22 minus 35 is -13. -7 times 13 is -13 is +91. -84 plus 91 is +7. -7 times 7 is -49, giving me a remainder of 0. Good, good. Then I'll take out an x minus 1. So bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. -13 plus 6 is -7. 1 times -7 is -7. 7 minus 7 is 0. What I have left then, I took out my 2 only zeros that I could find by graphing. Now I'm resorting to either factoring or algebra. This is 1x squared plus 6x minus 7 equals 0. And now I want to see if I can factor that. Are there two numbers that multiply to a -7 and add to a +6? We should all be nodding our heads in unison. Yes, Mr. Grahn, there is. +7 and -1. 7 times -1 is -7. 7 minus 1 is 6. This equals 0. We can just switch the signs for these. Remember that? X plus 7 is 0 when x is equal to -7. And x minus 1 is equal to 0 when x is +1. So my solutions, my 4 solutions, I found a -7 on the graph. I found another -7 through factoring. So that is -7 with a multiplicity of 2. I found a +1 on the graph, and I found another +1 by factoring. And so that is 1 with a multiplicity of 2. So -7's in there twice, and 1 is in there twice for a total of 4 zeros. All right, so let your teachers know if you have questions on this stuff. This is one of the last topics that we're going to cover in this quarter. It's not the easiest one because these are large multi-step problems. So let us know before it's too late, and hopefully we can get this wrapped up.